Hello everyone, I'm Xinyuan from AUS. I'm excited to present TART, an open-source tool-augmented framework for explainable table-based reasoning at the TRL workshop. Tabular data is everywhere in financial reports, travel schedules, and scientific research, but reasonings over the tables poses unique challenges for large language models. Let's consider the example here. The task is to determine whether Haley can reach the surfing beach in 4 hours using a boat schedule. But it has 3 challenges. First, the model must correctly interpret the table's layout, identify the headers, and extract the relevant information like the departure time and the duration to reach the destination. Second, it should calculate the total travel time involves performing exact numerical operations, such as finding the difference between arrival and departure times, which large language models often struggle with. Third, the reasoning process should be transparent, explaining how the relevant rows and columns were selected and how the final conclusion were reached. So these challenges highlight the limitations of the current approaches. The natural language-based reasoning might provide explanations but lacks precision results, but the program-based methods are accurate but often unreadable. So our work, TART, bridges this gap, advanced both accuracy and explainability. We designed 3 modules in our TART framework. The table formatter aims to standardize the raw table data by cleaning, aligning, and correcting errors. The tool maker module. This module dynamically generates the task-specific Python functions, such as retrieving columns or performing calculations like finding medians or differences. And the explanation generator. Finally, the TART produces the natural language explanations that combine the 2 outputs with the logical steps, ensuring the transparency and user understanding. To implement TART, we also developed the TOOLTAB dataset, a benchmark with the diverse real-world tables for tool integration. Using this dataset, we trained TART's modules on different open-source backbone models. Here is our results. We find that TART constantly outperformed the chain-of-thought methods across all 4 backbone models and datasets. If we see different backbone models, we find that CodeLlama 7b backbone achieved the highest accuracy, and the Llama 3 8b shows the least improvements. When comparing the different datasets, we find that FinQA shows the highest increase, while PubHealthTab shows the least. And if we compare the closed source model and the open source model, we find the closed source model as the backbone achieved the highest, outperformed the open source counterparts. We also do the tool analysis. For the tool distribution, from this chart, we can see that the table formatting and the numerical reasoning tools dominate the usage. For example, tools like the getColumn-by-name and the find-median are the most frequently used, reflecting the TART's emphasis on the table data preprocessing and the precise numerical calculations. For the tool generalization, we observe a strong overlap in the tool usage, particularly with the code pre-trained models like CodeLlama 7b. These models effectively reuse the tools, enabling the better generalization across unfamiliar datasets. When comparing the reused versus the correct tools, it shows some interesting patterns. For instance, the CodeLlama 7b not only reuses tools frequently, but applies them correctly at a higher rate than text pre-trained models like Llama 2 7b. In the future, we plan to extend TART to a multimodal framework by incorporating image-based QA and FV tasks to generate the richer explanations. In addition, we also plan to generate explanations to satisfy the needs of different end users, such as the laypersons versus the experts. To learn more, please visit our paper and GitHub repo. Thank you.